The third part is about rules for resource management supported by YUM.
Well, YUM supports management and allocation of two types of resources, memory and CPU. So how can user manage these resources? Actually, there are few configurations we can perform. The first configuration, yum.nodemanager.resource.memory.mb, indicates the physical memory size of the container running on Node Manager, expressed in megabytes. The value must be smaller than the memory size of the Node Manager server. And the second one, yum.nodemanager.vmem/pmem ratio, indicates the ratio between the maximum available virtual memory and the physical memory of a container. What's the difference between virtual memory and physical memory? The physical memory is our real memory. The virtual memory is a storage space on the disk, which is to improve the rate of data reading and writing. The ratio of virtual memory compared to physical memory is not allowed to exceed the limit. At last, the third one, yum.nodemanager.resource.cpu vcore determines the number of virtual CPU cores that can be allocated to a container. It's recommended that the value of this parameter to be set between 1.5 and 2 times the number of CPU cores. With these configurations, we can make better use of CPU and memory in the cluster. Ideally, the resource requests by YUM should be provided immediately. However, in reality, the resources are limited, especially when the cluster is busy. The application usually needs to wait a period of time to obtain the requested resources. In YUM, a resource scheduler allocates resources to applications. In fact, resource scheduling is a difficult task. It's difficult to find an appropriate policy for scheduling resource in all application scenarios. Therefore, YUM provides multiple schedulers and configurable policies, such as FIFO scheduler, capacity scheduler to enhance the efficiency. Firstly, let's have a look at capacity scheduler. Capacity scheduler allocates resources by queue. It's designed to run Hadoop applications as a shared multi-tenant cluster in an operator-friendly manner, while maximizing the throughput and utilization of the cluster. Multi-tenant cluster means the YUM cluster is used by different users or different kinds of applications. Traditionally, any application can use the whole resource to run, which is the most efficient method. But when we have a lot of programs that have to run at the same time, the method above will lead to resource premixation. This will result in the entire cluster running slowly or even unable to run. The capacity scheduler provides a strict set of limits to prevent a single application, user or queue from consuming too much resources in the cluster. Therefore, capacity scheduler supports the following features. Firstly, capacity assurance. All applications submitted to a queue will have access to the resource capacity allocated to the queue. Administrators can configure the limits of the capacity allocated to each queue. Secondly, flexibility. Temporarily, unused resource of a queue can be shared with other queues. However, such resource must be released in case of new applications submitted to the queue. Such flexible resource allocation helps improving the efficiency of resource usage greatly. But please pay attention. These loaned resources must be returned by existing users after the current work is done. Otherwise, forcing the return of a resource will cause the program to throw an exception. Thirdly, priority. This feature allows applications to be submitted and scheduled with different priorities. Higher initial value indicates higher priority for an application. The default application priority is FIFO, which means first in, first out. Fourthly, multi-leasing. A comprehensive set of limits are provided to prevent a single application user or queue from taking up too many resources and making other programs unusable. Fifthly, dynamic update of configuration files. As the administrator, you can dynamically modify configuration parameters as required to achieve online cluster management. The stopping of programs may cause the interruption of a business. So, the dynamic adjustment of configuration information helps to reduce the impact of resource configuration changes on the business. Let's see how the resources are located by YUM. Well, in YUM, resource scheduler organizes resources through a data structure called tree. Particularly, a tree contains a root node, which is on the top of the structure representing all of the applications in YUM. Then it is split into several branches, which are called parent nodes, representing different kinds of applications, such as MapReduce, Spark, Flink, and so on. We have learned MapReduce in this chapter. Spark and Flink are also data computing components, which is similar to MapReduce, and I will introduce them in details in subsequent chapters. Each branch splits again into more sub-branches. We call the nodes in last layer leaf nodes or leaf queue. Here we can see a parent queue can have multiple leaf queues. It means a MapReduce queue contains many MapReduce applications, which is operated on the leaf node. Now we have explained the organization of various applications on YUM. The next problem is how to allocate resources for these applications. So here goes the whole procedure. In the first two steps, the resource scheduler selects a queue from the tree based on certain algorithms and then selects an application in the queue. And then it attempts to allocate requested resources to the application. If an application is specified in the code that it should be operated in the MapReduce queue, then the scheduler will allocate the application to the MapReduce queue directly. But if no queue is specified, the application will be allocated to the default queue. After the scheduler selects an application, the applications have many resource requests, so we need to decide the order. Here, in the blue box, we can see the order decided by the scheduler. The scheduler first satisfies the request for local resources, and then for sources on the same rack, and finally for resources from any machine. This setting helps to reduce the cost of data transfers.
In this section, we learned the rules how YUM manages the resources. Then we are going to learn some enhancements of it.